Hello, this is Scholastic Sam. Welcome back to my math and science educational YouTube channel. Today in our second lesson 1.2 for Algebra 2, we will be learning about the basics of parent functions and how to identify them. Now, a parent function is the base of a function that can be shown by graphing, as we'll look at today, or explained through investigation, as we'll look at in future videos. Now, the parent function, all the functions and equations that you'll learn about in Algebra 2 will come from one of these parent functions. There are 9 of them. They are constant, linear, cubic, quadratic, radical, absolute value, logarithmic, exponential, and rational functions. So go to the first one, constant. Now the equation for this is just y equals a. It's pretty simple. Whatever a equals, which is some constant value, that's what y is going to equal. For example, as we see f of x equals -3, a equals -3, so that's what y is going to equal. It's going to be a straight horizontal line. Now we go into our next one, linear. The equation is y equals x, or to be more complex, y equals mx plus b. You guys also know this one for Algebra 1. This is going to be a diagonal line, and it's going to be odd, meaning that it's going to be positive on one side and negative on the other. Here we have quadratic, which is y equals x squared, or y equals a quantity x minus h squared plus k. This just means that it's a bunch of stuff that you do where you multiply x, you subtract from it, and you add to it, all that to modify your function. Now this, to identify it, it's going to be two sides reach one function, and they will be a reflection across a vertical line. If you have a vertical line going through that point, you will be able to reflect both sides off of that point, or off of like the vertical line, and you will get the same function. Now they collide and reach that point, and it's curved. Many people get this confused with absolute value, which we'll look at soon. But that is just two straight lines, but this is curved. As we can see, is the parent function right here, y equals x squared. We see x is 2, 2 squared is 4, and y equals 4. Here we have cubic, similar to y equals x squared, but it's y equals x to the third power, or y equals a quantity x minus h to the third power minus k. Now this is odd. Well, quadratic was even. Even means that the end behavior is the same. On the left side, it's either positive or negative, and on the right side, it's the same. So it's going to be either 2 positive or 2 negative if it's even. But if it's odd, one of the sides is going to be positive and one of the sides is going to be negative. This is another odd one. As we see, the left is negative and the right is positive. And you can tell this is a cubic function because it'll be very quick. It'll shoot up and down in values. And then there's a little plateau around the middle, the point where it can be reflected off of, and then it shoots again. As we see, if x is 2, 2 cubed is 8, so you can't really see it. You can't see it on my screen, but y would be 8. Here we have radical and square root. Now, this is y equals the square root of x, or y equals a zth root of x minus h plus k. Now, I went kind of overboard on the complexity because usually you're just going to use the square root, but every once in a while you'll see one that's like a fourth root, but z has to be even because if it wasn't, then there would be points, there would be two y values for one x value, and you can't have that. It has to be a relation and not a function. Now, it starts from one point and goes in one direction, and it's going to be slightly curved too. You're going to see one point, depending on which things are negative and reflected, it's going to either go up or down to the left or right in sort of a curve where it starts off high and then it sort of plateaus a little bit, because then you're going square root of 39, square root of 40, square root of 41. Those are very close. So yeah, so we see 4 right there. The square root of 4 is 2. So when x is 4, y is 2. Here we have rational. Rational function is y equals 1 over x or y equals the quantity of a over x minus h, or quantity x minus h, plus k. Now this one's kind of confusing. It looks like there are two different equations, but really it's just one, because as you can see, there are never 2 points where one x value has two y values or one y value has two x values. But we can see there's a horizontal and a vertical asymptote. This just means that horizontal asymptote, which means there's, for some y value, if you draw a line, it'll get close to that but never reach that. And vertical, if you have a line for some x value, it'll get close to that but never reach it. As we can see, both are x equals 0 and y equals 0. Now, as we can see, let's say if we have 1 over x, we have 2, y is 1/2. When x is 2, we can see that y is 1/2. We're going to exponential. Now, the full equation is y equals a b to the cx plus k plus d. And the variables can be interchanged with different letters or signs, but that's going to be very uncommon in just algebra 2. Usually you'll just use y equals b to the ax plus k, but because, of course, we can't have it for all b values and all x values, so we just chose 2, which is common to get the concept started, so y equals 2 to the x. This will have a horizontal asymptote and be curved. It'll be, like what you see here is x is 0, or 2 to the 0 power is 1, because anything to the 0 power is 1. And it's kind of like, it's going to be shaped in some sort of modified C. And it's going to look like that. Now, the inverse of that is our next one, logarithmic functions. This is the inverse, which we'll talk about later, of exponential functions. We have y equals the log of x. Log is logarithm, or the more complex version. Y equals a log of b, quantity x minus h. And they're supposed to, right there, x minus h plus k, because the k would affect the y values in the end. And this will have a vertical asymptote. And this is sort of hard to understand, but what you're seeing right now, it's just the base value, which of that graph is going to be 10, because when you don't write a base value, it's assumed to be 10. 10 to what power will get you x? So we have 10, x is 2. 10 to what power will get you 2? And it's like around 0.25. Or if we want to look at, or if we look at just above 3, we have x is 10 to the about 1/2 power equals just over 3, as we can see in the graph, because the square root of 10 is just over 3. Now we get to our final one, absolute value. Now this is actually a piecewise function, which we'll talk about later, meaning that it's not like one continuous thing. There's a point where one thing ends and another thing starts. Now the idea of absolute value is that it's the distance from 0 on a number line. For example, you have 2, which is 2 units from 0 on a number line, but -2, which is also 2 units away from 0 on a number line. It's either a V-shaped, or if it's negative, it'd be shaped kind of like a triangle or a party hat that you wear, but in 2D. And you see it's 2 lines on the left and right collide. Remember, quadratic was curved, but the ones on the left and right, they just go downward, as we see there, and collide. Now, as we see, the basic equation is just y equals the absolute value of x. That's what's shown there. Now, you see, if x is 2, y is 2, because the absolute value of 2 is 2. And if x is -2, y is 2, because the absolute value of -2 is 2. Now, I hope you guys enjoyed this and learned a lot about identifying parent functions. In my next video, we will talk more about parent functions, more the complex versions, and how each part of the equation affects the graph, so we can fully understand the equation and the graph. And after that, I'll do my lesson on investigating functions, which really shows you how to fully explain a function and all the important points. I will do that for all of the parent functions and all of these functions, because all the graphs you'll see in Algebra 2 will be some sort of modification or variation of these functions. So I'd like to give a shout out to Mr. Barrett, my math teacher, for teaching me all this information. And if you guys could like and subscribe, it helps grow the channel and helps this knowledge reach more people. And if you could turn on post notifications, ring that bell so you can get notified when I post new videos that will be about science, math and science courses, or anything really that you guys need, courses that you're taking. So it'll help you ace high school with ease. So bye, guys. Thank you. And remember, knowledge is power.